times. What are the two things you've done many times?
5x.
5x squared and 3. What's the derivative of 3?
Nothing.
Nothing. It's 0, right? So it goes to a big 0, right? And this is 10x. So what's the only new one there?
2x.
2x. And what did I tell you before? d dx of a to the x. What's the derivative of a to the x?
ln a
times a to the x. So what's the derivative of 2 to the x? ln 2 times 2 to the x. That's just the formula. Yes, no.
B, 1, 6, B, and C.
X-axis?
Yep.
So we're okay with this one? Okay. Find the equation of the tangent line to the curve at that point. The tangent line to the curve at that point. Well, the tangent line is going to be, you need a point and a what? Slope. So what's the point? Well, we have the slope already, right? There's the slope. You found that in A. So to write the equation of a line, you need a point and a slope. You have the slope, so you need to find the point. So how do you figure out where it crosses the x-axis? What does it mean to cross the x-axis?
To go through.
When a graph crosses the x-axis, what is true?
X is 0.
X is not necessarily 0. Look, if you're crossing the x-axis, what is 0? What is the common thing about all these points? Y is 0 in all of these points, right? So what do you do to find where it crosses the x-axis? You set this equal to what? 0. You want the output to be 0. Kids, this is Algebra 1 stuff. Where does a graph cross the x-axis? It crosses the x-axis whenever y is 0. Where does it cross the x-axis? When x is 0. So y is 0 is the output. So when is this true? This is when e to the x is equal to 1. When does e to the x equal 1? When x is equal to what? No. What?
Oh, 0.
0. Exactly. You know this. You definitely know that. Anything except 0 to the 0 is 1. So the point is 0. So if you have a slope and a point, can you write the equation of a line? Yeah, it's y minus 0 is equal to negative 1 times x minus 0. What does that simplify to? Negative 1x. C, find the equation of a line perpendicular to the tangent line. Perpendicular to the tangent line. What does perpendicular mean? If a line has a slope m, what's the perpendicular slope?
It intersects it to make all 90 degrees.
Correct. That's what it creates, but what is the perpendicular slope equal to? If the slope of one is m. The what?
The negative reciprocal.
The opposite reciprocal. Exactly. So this one would be negative 1 over m, right? So if the slope of the original, if the slope of the curve, if the slope of the tangent line of the curve at the origin is negative 1, what's the perpendicular slope? Negative 1 over negative 1. What's the opposite reciprocal of negative 1? 1. The opposite reciprocal of negative 1 is 1. So it's going through the same point. Oh, now you just have y equals x. That's it. The key thing about perpendicular is it's opposite reciprocal. What do you think the common mistake? People forget one of those things. They just do the opposite. Or just the reciprocal. They're like, oh, the slope is 3/2, so the perpendicular slope is 2/3. Nope, that would look like this. Or they just make it negative, and it's not the same. You need to do opposite reciprocal. Opposite reciprocal. Opposite reciprocal. Exponential, so you've done this many times here. It's y is equal to ab to the t. So what are we solving for first? What do we need to find? Well, b, and we know that b in this case is going to be 1 minus 0.10 because it's going down by 0.10, 10%. So there's your reduced at a rate of 10% per year. It's asking how long it takes for it to go down by half, right? Do we know what the starting value is? Do we know what A is? Does it tell you what the informal mortality rate is to begin with? So what that means is to go down by half, reduced by 50%, A turns into what? 0.5A. If A is the starting mortality rate, to go down by 50%, it turns into 0.5A. What cancels now? The A cancels, right? The A cancels right there, leaving you with just this. How do you solve this? What do you need in order to solve this? Log or ln, or you can put it into log form, or you can just take log of both sides, or you could just take ln of both sides. Are all of those valid methods? Yeah, the reason we do that, why do we take log of both sides? What's the cool thing it allows us to do? Put the exponent in the front. So then you can isolate t, and you get t is equal to log 0.5 over log 0.5 over log 0.9. That is the same thing as ln 0.5 over ln of 0.9. Yes. Effectively, yes. Yes. That's effectively the same. So how long does it take to reduce by half? Yeah. So it effectively is asking for the half-life. Yes. Very
I
cool.
was asking reduced to.
You are going to use a lot. The product rule and the quotient rule. They look like they're super heavy notation, and it's not immediately apparent why they're useful, but they are very, very useful. So we're going to talk about them one at a time. One at a time. If I asked you right now, let's say I said g of x is equal to, let's say, I don't know, e to the x times 2x squared, or let's just say x squared. We don't currently have a method for finding that derivative by hand. Is there any way to simplify that? No. Is there any way to combine the terms? No. The bases are not the same. The powers aren't. You can't do much with that. But what do you see? How many functions do you see multiplied together? You see a first function and you see a second function. You also might be tempted to think, oh, I'll just do the derivative of the first times the derivative of the second. So people, when they originally see these, they're like, oh, well, what's the derivative of e to the x? They might guess this. G prime of x is, well, what's the derivative of e to the x? ln e to the x, which is this e to the x, right? And then what's the derivative of x squared? So people are like, oh, I'm done. No. You don't just take the derivative of the pieces. This is what the product rule says. The derivative of two functions multiplied together is the derivative of the first times the second plus the first times the derivative of the second. G prime of x is going to be, what's the derivative of e to the x? E to the x times the second function plus the first function times the derivative of the second. What's the derivative of the second? This is the derivative of g to the x. If you have two things multiplied together, it's the derivative of the first times the second plus the first times the derivative of the second. Now you can change that order because what does a plus b equal? B plus a. You can take these terms. The order I just told you is what I like. It's this one right here. If g of x is equal to h of x times, let's say, j of x, then g prime of x is going to be equal to the derivative of the first times the second plus what? The first times j prime of x. That's the order I'd like you to write it in. It'll help us talk to one another and also do them on the board together. If you learn it in a different order, it's still true, but it's harder to have a common language about it. That's all the product rule tells us. This is super, super helpful because it means we can sometimes, A, do derivatives we couldn't do before, but also not have to multiply some stuff out, which is huge. So for example, let's say I gave you g of x is equal to x squared minus 1 times x cubed plus 3. Before, if I gave you that, what would you have to do first to do the derivative? You'd have to multiply it all out. Well, how many functions do you see multiplied together?
2.
I see 2. I see this function, and I see this function. Well, the product rule tells us that g prime of x is going to be, what's the derivative of the first?
2x.
2x times the second plus the first times the derivative of the second. What's that?
3x.
Done. That's it. We didn't have to multiply it out. Now, if you had to do anything more with that, you might have to multiply it out to simplify. But if I just asked you for the derivative, you can stop there for now. Is that the derivative? Yeah. Could you multiply it out and put everything in a proper order? Sure. But the new thing is you can now do that derivative. Let's practice some of this. Oh, I just want you to tell me what the derivative is. So y prime is going to be equal to what? 3x squared times. You notice how I put parentheses around it? It just kind of helps me differentiate what's going on. 4 to the x plus what? Yep. Times. Yep. Yeah. That is the derivative. That's great. Perfect. There it is. Now on this one, can you just do the derivative of this one straight off? Yes, you can. You know what the derivative of e to the x is. This one's pretty cool, actually. You just know what's the derivative of e to the x. So what's the derivative of e to the 5x? It's the same thing, right? So you know just by the rules you already know that the derivative is itself, right? But let's use the product rule. Do you see two functions? I do. What's the first function?
5.
Exactly. The first function is 5, and the second function is e to the x. Let's do the product rule. Should we end up with the same thing?
Yeah,
What's the derivative of 5?
0.
0 times e to the x plus the derivative of the first times the, what's the derivative of e to the x? ln e to the, I'm just doing it out the long way just to make it the story longer here. But what is ln e?
Well, that just still comes out
I know, I'm just showing, should they come out? If it's a rule that works, it should work for everything. If it doesn't, it ain't no rule, or we have to be very specific in the definition. So when we have two things multiplied together, we have the product rule. You will use this thousands of times in calculus. You'll use this all the time. All the time. The key thing to focus on right now is remember derivative of the first times the second plus the first times the derivative of the second. We okay with this? We pretty good? Okay, so do you remember what the other rule was called? Called? I don't know what that's coming from. Yeah.
I don't know what the other rule is called, but I was just...
When you have a function like, let's say, g of x is equal to a constant times h of x, the derivative of g of x is always c times the just what? Derivative of h of x. The coefficient is along for the ride. And what is the derivative of e to the x? Exactly. So what is, if you had, let's say, n of x is equal to a constant times e to the x, what's the derivative always going to be? C e to the x itself. A constant times e to the x, the derivative. You'll love e. It's super helpful. Okay, so here's this. What's different about this? Is this multiplication? No. You can force it to be multiplication by making x squared what? Yeah, so you could say y is equal to e to the x times what? X to the what? Okay, so if we do that, could we use the product rule now? Yeah, lead me through it, David. What's the product rule going to tell me? Y prime is equal to what?
E to the x.
Times?
X negative.
Mm-hmm.
Negative squared.
Yep. Plus what?
E to the x.
Yep.
Negative 2x.
To the what?
Is it to the 2? Yeah.
Negative.
Is it to the negative square?
Negative. Nope. Can someone help him?
3.
Negative 3. Power go down by 1, remember?
Oh, that's right.
Powers go down by 1. So do you agree that that's the derivative right there? So sometimes you can take something that's a quotient and turn it into a product. You can always do that. There is a quicker way, though. Here's a phrase I need you to memorize. Here it is, right? It should be in red here. Low d high minus high d low over low squared. I want to give you 30 seconds to memorize that. For what was it? It was f of x was e to the x over what? So what was that first block? So low d high, what's that going to be? What's the low function? What's the derivative of the top? Yeah, the reason e to the x is used initially is it makes things simpler for us. Minus what? Low, that was low d high minus high
Minus 2x.
Times 2x all over what?
X to the 4th.
X squared squared. Yeah, I'm just writing it out like that. You with me so far?
Yes.
Okay, so that is the derivative, right? Did we already find the derivative? We found the derivative using the what rule? The product rule. So let's go back to this. We found this. Does that look like it's the same thing?
No.
It does not. Let's take a look at it. Let's take a look. So we did it, if I can find it here. That was one answer we got, right? What was the other one? It's this one right here. Now, what might you suspect? So we just did the derivative two ways. If they are both valid ways of doing it, if they are both valid, they should actually be the what? The same. How do we show or test to see if they're the same? Which one do you want to work on? The one on the left or the one on the right?
Right.
Let's work on the one on the right. So what does this equal? That's e to the x over what?
X squared.
X squared. And this is e to the x minus, what is that minus? Let's keep that on top. It's minus what? Minus 2 e to the x over what?
X cubed.
X cubed. To add fractions, you need a common what? You need a common denominator. Do you agree with that?
Mm-hmm.
Do we have a common denominator?
No.
No, we don't have a common denominator. So what do we need to multiply by?
X over x.
X over x?
Or no, sorry.
Yeah, we can do x over, yeah, that's fine.
Yeah.
Is that legal? Can we multiply by x over x on that 1? Why is that legal?
It's 1.
Because it's 1. So what do you end up with? X e to the x over what? X what? Cubed minus what? 2 e to the x over x cubed. Do we have a common denominator now?
Yeah.
So what is that? X e to the x minus 2 e to the x all over what? X cubed. Now, what's the denominator down here? What is that? So if we wanted to turn that into an x to the 4th, we need to multiply the bottom one by x to the 4th, but also the top as well. So if we multiply this by x over x, Is that legal? Why? Because it's 1. What do we end up with? X squared minus 2x e to the x all over what? X to the 4th. Hey, is that the same thing? You get the same thing. You get the same thing. This right here is the same as this. E to the x. E to the x, thank you. E to the x, thank you. Is it the same? It is. Sometimes you can use the product rule and it will be the same amount of work. Sometimes you definitely will want to use the quotient rule. Sometimes you'll definitely want to use the quotient rule. The key is just this phrase though. Low d high minus high d low over low squared. So if we go over to here, look at this next question right here. Let's take a look at this one. Using the quotient rule, do the derivative. Don't simplify it, just do the derivative for me. What do you end up with? Y prime is equal to what?
X cubed plus 1.
What's the next term? Somebody else. Next term. 10x. Minus next term, somebody? 5x squared. Next term, somebody else?
3x squared.
Yeah, and then all over?
5.
X cubed plus 1 squared. Done. That is the derivative. There it is. Stop there right now. For now, stop there. I'm not asking you to simplify that. It's not the point right now. The point is, can you actually find the derivative? That's it. That's it. Let's do the quotient rule on this one. What's y prime going to be? What's low? 1 plus e to the x. What's the derivative of the top?
0.
Ah, good. A really common mistake is for people to write 1 again. Minus what? Pi. And what's the derivative of the bottom now?
E to the x.
Just e to the x all over
E to the x squared.
squared, right. Now, could you simplify this a little bit easily? Sure. What can you cancel? That's gone.
That's just negative e to the x.
So what do you end up with? Negative e to the x, or if I could write properly, negative e to the x all over.
1 plus e to the x squared.
Yeah, done. That's it. These rules will be muscle memory to you. You won't have to think about it. You're just going to do them. You're just going to do them. You're just going. How do these look? They look pretty good?
Yeah.
Nice. Okay, let's keep going here. Let's keep going here. You can now ask this question. So we're going to start doing something here. I'll put it back up on the board. I'll make it a little bigger. H of x is this function, e to the x, x squared. So you've already worked with that a little bit. I want you to, by yourself, find where h of x is increasing. Just do that part for me. Just do that part for me. You have done this many times. Have you found where functions are increasing?
Yeah.
Yeah, we did a whole test on this. We did first derivative test, second derivative test. The only thing now that's different is the function is a little bit more complicated. So you did the derivative. I saw many of you do the derivative properly, and you get h prime of x is equal to the derivative of the first times the second plus the first times the. So if you want to know where that's positive, you first need to find out where it's equal to.
0.
So e to the x, x squared plus e to the x times 2x has to what? Equal 0? What can you factor out of both of those terms on the left?
E to the x.
So e to the x times x squared plus 2x equals 0, right? Everybody with me so far? E to the x. Can e to the x ever equal 0? That's correct. E to the x can never equal 0. This e to the x is always what? Greater than 0. So if you have two things multiplied together to equal 0 and one of them can't be 0, what does the other one have to be? 0. So x squared plus 2x has to be equal to what? 0. Many of you got this far. So you know that x, so what can you factor out of both of these?
X.
X times what?
X minus 2.
Plus 2.
Plus 2.
So therefore, what are the two answers?
0.
0, comma, negative 2. So then you make a sign diagram. And what are the two values?
0, negative 2.
And I'll put them in order here, sorry. What are they? Negative 2 and 0. So that's your x value. Now you want to do the prime, the derivative. So you need to test three things. How many zones are there? There's this zone, there's this zone, and there's this zone. So what do you need to do for each of those zones? Plug in numbers. So what's a number what's a number to the left of negative 2?
Negative 3.
So now we need to look at this right here, right? We're looking at the derivative. So let's plug in negative 3.
So we do need our calculators.
No, you do not. You absolutely do not. Do not cry home to mommy and daddy in the form of your calculator. Do this out. You are big boys and girls. You can do this. E to the x is always what? We already said this. E to the x is always what?
Greater than 0.
So it's always positive,
Oh, so
right?
it doesn't
You don't
matter.
exactly. We don't care what the actual value is. We just want positive or negative. Sometimes you need your calculator when it's really nasty, but you're free to choose whatever numbers you want in those zones, so you can find something to test here. So let me show you the nice way of doing this. Do you see this right here? This is a what? That's the derivative. Do you agree?
Yeah.
E to the x and x squared plus 2x. What number are we testing? -3. Well, that's positive. Do you agree when you plug in -3 into e to the x is positive? It's 1 over e cubed. Hold on, Alex. Let's plug in -3 here. What do you get when you plug in -3? You get 9 minus 6, which is what? So a positive times a positive means it's a, what is it? Positive. So this is increasing, right? Do you agree?
Yeah.
What's between -2 and 0?
-1.
Plug in -1. Well, this is still positive, right? But then what's the next one become? 1 minus 2 is? Oh, what's it going to come out to be then? So this is negative, 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 negative. And then you plug in, what's greater than, plug in 1. It's going to be 1, and then what? 1 plus 2 is? It's positive. Well, you need to test it. Just make sure you test it. So it's going to be positive. So if I ask you, where is this increasing? Where do you say it's increasing? Negative infinity to? -2 union.
With 0, comma.
Yes. Did everybody see that? Be really careful of dividing when you do inequalities. Factor. Factor, 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 factor. You got a question, Alex?
Yeah.
You have to use the product rule twice. You have to use the product rule twice. The derivative of the first times the second plus the first times the derivative of the second. This is the derivative there. And then what happens? Plus... I haven't done the derivative of that one yet. Then it's the first times the derivative of the second plus the first times the derivative plus the derivative of the first.
Need a little more time.
So what do you see in each of those terms? E to the x, right? So what can you factor out of all of them? So you get e to the x times what? X squared plus 2x plus 2 plus 2x, which is e to the x times what? X squared plus 4x plus what? 2. You want to know when that's equal to 0? Is that nicely factorable? Nope, it's not. If it's not nicely factorable, what do you need to use? Yeah, there's no minus in the product. It's not minus. It's, all of those are pluses, Arvin, right there. The product rule is adding. You put in minuses. That's why. No. The quotient rule uses the minus. So in this, you want to say, oh, is this nicely factorable? And the answer is no. What do you use if you don't have a calculator and you have to solve that? Yeah. Yes.
But can I use my calculator for that?
No, you cannot. Again, you cannot. B squared minus, it's like everybody should learn how to drive a manual, not just rely on having access to an automatic your entire life. 16 minus 4 times 1 times what? This is the discriminant. What's the C value?
2.
2. So what's it become?
16 minus 8.
Hey, there you go. So what is it going to be? X is equal to -4 plus or minus the square root of 8 all over what?
2.
2. Is everybody with me so far? So what's that become? -2 plus or minus 2 root 2 over 2. So what does that become? -2 plus or minus the square root of 2. So there are two places where potentially the concavity can change. Potentially. So we now know where it equals 0. So what do we need to make now? We're not going to finish this, but what do we need to make now? We know where it equals 0. We make a sign diagram, but we're making a sign diagram with the second derivative now. -2.
There's no -2 when we take out that 2.
Well, it's what's -4 over 2?
Oh, never mind.
I did that halfway. So what's here? -2 minus the square root of 2. And what's this? -2 plus the square root of 2. So then how many zones do you have to test? 1, 2, and 3. Each of those zones could be concave.
Points of inflection.
They could be points of inflection if the concavity changes, right? If the concavity changes. So you'd have to plug numbers into the second derivative now. Okay, it's 10:20. Game over.